Good afternoon. Welcome to our webinar, Driving Business Intelligence from Operational Systems. My name is Paul Gant. I'm the VP of Sales for Clusterpoint in Europe, and I'm joined by my colleague, Jurgis Orups, who is the CTO and one of the co-founders of Clusterpoint. So what we're going to do today is give a short overview of Clusterpoint, which we tend to do on every webinar that we run, but we're going to particularly focus on the ability of Clusterpoint to derive business intelligence from a system which is actually running as an operational system. So rather than being a separate standalone data warehouse with a cycle of updates and feeds, this is how you would derive business intelligence from a system which is actually at the same time being used as the core operational system for a certain area or areas of the business. So that's the background to this. Now, as always with these webinars, I'm afraid that participants do need to be in a muted mode. Given the numbers of people who join these sessions, there will be too much background noise to have everybody participating on an audio channel. So you will see that you are in a muted state. But the way we handle questions is if you do have questions that you'd like to ask, please type them into the questions pane on the GoToWebinar panel that you will have in front of you. And what we will do is at the end of the session, when Jurgis has presented at Clusterpoint, we will then go through the questions that have been asked, and hopefully we'll have enough time to answer those within the half hour that we've allotted. If anybody would like to continue after the 30 minutes, then we certainly will be happy to do that and answer any more questions in further detail. So, I think really, let me just move into this straight away. And first of all, give a bit of background to what Clusterpoint is about. We call Clusterpoint a hyper-performance database management system. You may know this as a NoSQL database, a next-generation database. It also contains multi-model database capability. But there are key elements to this. It's about speed, it's about capacity, it's about being able to scale, and it's about flexibility of data that can be held in the system. In short, Clusterpoint manages datasets that are otherwise unmanageable. There are a number of aspects to this, but I think the most important thing for me is the third point on the list there. Crucial business projects are stalling through an inability to handle the underlying data. Clusterpoint addresses that head on, and here is a particular use of Clusterpoint. We'll be going very briefly over other potential uses of Clusterpoint later, but this particular one that we're looking at here is the business intelligence requirement. So what is it about Clusterpoint that makes it able to deliver against this requirement? Well, all NoSQL databases purport to offer what is known as the 3 V's, velocity, volume, and variety. So velocity, how fast can I get information into my database? How many transactions can I run per second? And that's about the velocity. The volume is how much data can I handle and process in total? What is the total size of the stack in terms of what I can address? And thirdly, how can I manage different types of data in the same database? So how can I manage a variety of different data types, whether those are conventional items that we might think of being numbers, text fields, date fields, right through to unstructured free text, which is also incorporated in the database, and how can that database be expanded around those different items? Those are the core 3 V's of a NoSQL database. We also, with Clusterpoint, offer a series of extra capabilities which, whilst individually are not necessarily unique, taken as a set, we believe they are. And it's these aspects, certain of these aspects, which enable the capability that we're going to talk about today. 2 in particular. The first is scalability. So the ability to grow the database's capability by adding further nodes, which are represented by servers, and then growing the ability of the system to process, whether that's processing new data coming in, or processing queries, or processing the 2 simultaneously. Scalability is key to getting the right level of performance at the right cost. The second is transaction integrity. Now, for those of you who are from a database background, the term ACID compliance, you'll understand the atomicity, consistency, isolation, and durability of database transactions. That's what ensures that when a transaction is posted from wherever it's posted, either the entire transaction is posted across the entire database or none is. If it's none, of course, you know it is. It will tell you the system has not been able to post that transaction. Why that happens is that you must never have your database get out of synchronization so that you don't have everything that you need posted into the system. So taken together, transaction integrity and scalability are the things that most underpin the topic that we're discussing today. And taken together, those 6 facets of Clusterpoint give, we believe, a very uniquely striped capability within our database solution. To just add a little bit of data or context or specific data points, if you like, behind the scalability piece, let me give you some idea of what we mean by scalability and performance. So here we're looking at a graph showing the ingestion of records per second plotted against the number of nodes in a database. And I think that the most interesting thing for me is to see how pretty much that is a straight line. So if you actually apply those different extra nodes, you will see against the chart as plotted here, let me just turn this laser pointer off, you will see here the total number of records that you are able to ingest per second. With one node alone, with one server, Clusterpoint will ingest 24,000 read-write transactions per second, scaling right up to here to 60, which is as far as this graph goes, up to just short of 1.4 million records per second being posted. That gives you some idea of A, the capability of the system to provide that level of performance, and secondly, how it grows in pretty much a straight line. Now, what this means is that we are able to deliver what Gartner have termed HTAP capability, which is hybrid transactional analytical processing. The transactional piece is posting, the analytical piece is querying. And this is represented, I'd like to think, fairly clearly here, where we have multiple read-write transactions, and rather than sort of showing 4 there, we could be showing thousands, as you've seen on the previous slide, into the Clusterpoint database, and concurrently with that, be running multiple analytical queries, which provides the sort of output that people tend to need in an operational analytical database. It's a very important facet of Clusterpoint's capability. So this capability and Clusterpoint in general has not gone without note. We are one of Gartner's cool vendors for a number of aspects of our capability. And for those of you who are interested, this is something we can go into more detail in a future discussion. So to finish the introduction to Clusterpoint, there are a number of reasons why our customers deploy the solution. They're listed here. I'm not going to read those out. But the first one is what we're talking about today, which is operational reporting with simultaneous analytics. So on that note, what I'm going to do is now hand over the screen to my colleague Jurgis. And then when Jurgis has picked up with that, I'm just going to briefly talk myself about what you're seeing. So that's great, Jurgis. I'm seeing your screen. So before I hand over to Jurgis to move into the actual technical demonstration, let me describe what you are now seeing in front of you. Please imagine that you are running a cloud services provider. You are running these services online. Your clients can purchase different cloud service capability through an online portal. This is happening in real time, and people are purchasing these things regularly, you hope, and in large numbers, and so you have a lot of operational transactions coming into the system. What you're seeing here is relatively straightforward statistics and analytics coming back from your system, your revenue earning system, your transaction posting system. What you're seeing on the top line here is the revenue that you have earned historically. This is in euros. Each year, between 2016 going back to 2011. So what you're seeing there, and Jurgis will describe soon how that color banding there breaks down different types of products. So you're seeing, first of all, the revenue you have earned as the owner of this cloud services provider over the past 6 years. What you're then seeing underneath there is how that revenue is distributed. First of all, by product. In this case, you are selling CPU power, disk snapshot capability, ISO file stores. These are quite technical terms, but this is the business that we're in, cloud services provision. So what you're seeing here is how is the revenue that you are generating as a business mapping against the products that you sell. The second thing you're seeing here is how does the revenue that you're earning map against your biggest customers. So you can see here you have a big chunk of customers which are outside of the individual analysis. So there's just others because you may have thousands, if not tens of thousands of customers. But there are some customers here who are generating significant proportions of your revenue. And what you want to be able to do is to glance at how are these customers doing? Are there ones that stand out and are important to you? There is in actual fact a third allocation here. This gets a little bit more technical, probably not worthwhile drilling into too much today, but it's just showing you really on this particular screen a representation of a third data point. Now, this is using this analytics dashboard here is using a product that we partner with called Zoom Charts. You may have any other number of analytical tools that would query into Clusterpoint, Tableau, Click, and others, MicroStrategy, etc., are ones all capable of drilling into and providing the analytics that you need. We're just using Zoom because we believe this is something that's nice and straightforward to show you. Before I finally hand over to Jurgis, let me just finally say that how we are going to demonstrate the capability of this to run analysis at the same time as bringing in data, you'll see the point here that we have in the top right, where we are able to increase inserts. And one of the things that you will see Jurgis do as he starts his demonstration, as he runs through it, is we will push that button and that will then start to trigger a number of records being posted to the system. And what that will allow you to see is the performance of the system and contrast that without any inserts happening and what happens now when we start to post more and more transactions to the system. I find this a really exciting demonstration because it's bringing to life a real-life system as best as we possibly can, other than showing an actual client system in use, which clearly would not be appropriate. So I hope I haven't taken up too much time there, just setting the context, but hopefully that will give you a better idea of what you're seeing here. So on that note, Jurgis, let me hand over the reins of the audio to you.
Hi everyone, thanks Paul for this nice introduction. So yes, as already Paul mentioned here, you see the cloud service product performance dashboard. And yeah, to bring you up to the speed where we are with this, this is the web application which is developed using PHP programming language, and we use JavaScript charting library to draw those nice interactive charts. And in a couple of seconds, I will show what this dashboard can give to business owners. So with the first upper panel of this web interface, you see the time chart. So when we go on the bar with the mouse pointer, we see breakdown of particular product revenues generated in 2016. So this screen was generated on the fly. So we asked database to aggregate data by year and by the product, and in the result we got the information that we can display in this nice time chart. So what we can do here, we can drill down into here to see the breakdown on the monthly basis. So you see that the same information, the breakdown of the products are there, but now they are not just in the years, but it's divided into the months. So you see it here, like in November, this pink product, which is virtual machines, was generating around 4 million euros. For example, here we can see this blue one, like ISO files, we're generating 1.3 million, etc. So you have a nice view on the split off of your products sold by months. And here down we have 3 nice pie charts, and each of those represents some information about your products. So in the first pie chart shows the distribution, revenue distribution by product. And what we can do here, we can easily click on particular product to check out how this product was sold in 2016. Let's click on virtual machines. You see that when I clicked on this pie chart, the database filtered out the data for 2016, and also other pie charts were updated automatically. So when I click back, you see those charts are redrawn, and this time chart also is redrawn. And each graph generation requires data aggregation at the database. So similarly, we can filter out also the revenue generated by particular customer. For example, let's click on this one. And you show, and this shows and refreshes the full set of the charts here. So this particular customer generated this amount of revenue each month, split it by those products, and here we see particular product breakdown as a pie chart. And also we can filter out particular product here. For example, CPU cores used by this particular customer in 2016. So we can actually drill down deeper to some specific dates. So now we have some data for November 22nd. We can drill down into that as well to see the same split of information and distribution of the same information, but now on this current date that we have, which is November 22nd. And similarly, we can click whatever we want and filter out by product, by customer. The data that are stored into the database are quite simple. We have some parameters assigned for each record. We have some values, some price, and actually the client. So this set of the information is used to draw those nice charts. Okay, so this is the basic drill downing into the data. Let's move back to where we started, and I will zoom out just to the level of years here. Okay, we'll group by years. We'll zoom out, and now I will turn on the feature that the Paul was referring in the presentation at the start of this webinar, where we will present how the same analytics that we did before is also applied to the system where there are new records coming into the system. So we are simulating the real operation system. So let's click here. So you see that the process now is generating around, at the moment, 2,600 records per second. So we can increase a bit more, wait a bit. So now in the system there is coming around 5,000 records per second. So let's drill down again and see how it works. You see that there is a not noticeable change in the performance when we do some analytics here. We can drill down to this level, click on filter out some new data by product, by customer, and we see that the records are still coming into the system. And all those queries are run by the real system, by operational system. I will zoom out. We'll split this one. We'll zoom out to the year level, and you see that we quite fastly generated new data into the November. So you see the spike here coming higher and higher. But still, we can navigate through the results set, do some filtering, etc. Okay, so that's shortly about this demonstration. So again, we were trying to show you that a Clusterpoint database is capable of doing both workloads in parallel. Analytical workload, which is generating the queries to the database, and at the same time loading the data at quite high rates of records per second to the database. Paul, over to you.
Jurgis, thank you very much indeed. So let me just really recap what you have seen there. I'm aware that showing demonstrations of this nature in a sort of a 15-minute timetable with lots of lovely swathes of color and moving graphics, sometimes you can sort of get lost in what you're seeing and forget the significance of what you're seeing. So what you saw there was some really powerful crunching of data. What we were doing was drilling in real time into a huge data set of information, slicing, dicing, cutting that information in myriads of different ways. It's almost something to take for granted, or it's easy to take it for granted when you see it, as to what computing performance Clusterpoint is delivering in order to be able to do that. And that's the thing that you saw first. What you then saw was all that happening, all that crunching and slicing and dicing of data at the same time as thousands of records per second being ingested into the system. That really is quite special. This is this HTAP capability, the hybrid transaction analytical processing, which we talked about earlier. And what I'm really just wanting to finish off on is to remind you of the capabilities in Clusterpoint which enable this possibility. And of the number of capabilities that we're showing here on our unique set, it is these two. It's the transaction integrity to be able to safely and assuredly bring in operational transactions into Clusterpoint, knowing that there will be no data loss because we have this full ACID compliance. And secondly, the scalability that regardless of the volume of transactions that you are likely to find yourself with, you will be able to scale across commodity hardware. In other words, hardware at a very reasonable price point to the level of database capability that is appropriate for your organization and its needs. So that's what we've seen. So really all that remains is to invite any questions. I have so far just one question, and I think I need to put this to you, Jurgis. I suspect it's not going to be an easy yes or no answer. There's a question from Adrian, which is what sort of performance could we expect to see in terms of transaction numbers and query numbers simultaneously? Because what we saw on our chart was total ingestion numbers. So if you could give some color or response to that, if you would, Jurgis, that would be helpful.
Sure, no problem. Yes, as the Clusterpoint database is distributed, uses distributed architecture, so the workloads that are applied to the database can be scaled. Either they are data ingestion or either they are analytical processing. So it really depends on the data structure, etc., etc. But in general, we here are speaking about thousands of records per second coming into the database, and by meaning thousands, it's like 10,000 or 20,000 records per second coming in, and still you can get the analytical queries execute in milliseconds. Of course, there could be some more complex analytical queries run against the data. It could last a bit longer, like seconds, but still it's very, very short time, and that could be used in various BI applications, and it could give end customers a good experience working with such a BI application.
Okay, thanks, Jurgis. Adrian, what I would say is if that's a topic that you would like more information on and you'd like to drill into some specific data sets that you may have in your business, then we'd be very, of course, pleased to engage in that conversation. Okay, so I am seeing no more questions coming in. So in that case, all it remains for me to do is to thank Jurgis for his presentation and to thank all of you for attending. I always enjoy these sessions. I hope you have gained some value from that. And I would, of course, be delighted, as would Jurgis, to hear from you if you have any further questions that you would like to address with regard to your own computing needs. So on that note, thank you very much indeed, and good afternoon.
Thank you. Bye.